Assalamualaikum and hi to everyone. My name is Muhammad Afiful Haq bin Iskandar Shahsami. My metric number is CN240143. Today I will present our project titled Engineered Resilient, Designing a 33 kilovolt overhead line insulator for polluted environments. This project focused on designing an overhead line insulator that can operate safely and reliable in areas with high levels of pollution, such as coastal and industrial environments. In this presentation, we will explain the problem, the design requirements, and our proposed solution. Okay, firstly, the problem statement. Overhead line insulator play an important role in supporting transmission lines while providing electrical insulation. However, in polluted environments, contaminants such as dust, salt, and industrial smoke can accumulate on the insulator surface. When the surface becomes wet due to rain or humidity, these contaminants create leakage current. If the leakage current becomes too high, it may cause flashover, which can lead to power outage and damage to the transmission system. Therefore, a more reliable insulator design is needed to reduce this risk. And then we move to the design requirements. Our design is intended for a 33 kilovolt transmission system. Based on the design standard, the insulator must achieve a minimum creepage distance of 700 millimeters to improve insulation performance in polluted environments. At the same time, the overall length of the insulator should not exceed 300 millimeters due to installation and mechanical limitation. Therefore, our challenge is to achieve both high electrical performance and a compact design at the same time. Okay, then we move to our concept of the design. The main idea of our design is to increase the creepage distance so that the leakage current has a longer path to travel, reducing the possibility of flashover. We also optimize the shape of the insulator sheds to improve the electric field distribution and reduce electrical stress on the surface. By combining these two approaches, the proposed insulator can provide better performance, higher reliability, and longer service life in polluted environments. So then I will pass the presentation to Muhammad Ikwanafi.
Thank you, Afiful. We selected a polymeric insulator because it performs better than traditional ceramic insulators in polluted environments. Silicon rubber has a natural hydrophobic properties which help prevent continuous water films from forming. The core rod is made of fiberglass reinforced polymer or FRP which provides high mechanical strength while maintaining good electrical insulation. Next is our design comparison. We developed two design concepts. Concept A uses an alternating multi-shed arrangement while concept B uses a bowl and cup configuration. After comparing both designs, concept A was selected because it provides better water drainage, lower pollutant accumulation, and achieve the required creepage distance within the design limits. For these lights, the insulator consists of steel and fittings and FRP core rods and alternating silicon rubber sheds. The alternating shed sizes help break the water path, reduce pollutant accumulation, and improve overall insulation performance. That's all from me. Next, Azhari will explain the simulation process.
Hello, Assalamualaikum. My name is Muhammad Azhari bin Muhammad Yusof. My matrix number CN240054. So, I wanna make a slide presentation about FEMM simulation. So, after completing the design, we analyze it using FEMM software. First, the geometry was created and the material properties were assigned. Then, one end of the insulator was set to 33 kilovolt, while the other end was grounded. Finally, FEMM calculated the voltage distribution and electric field distribution. Okay, next for clean condition. Under clean conditions, the voltage distribution is smooth and uniform. Although the electric field is slightly higher near the shade edge, the values remain within an acceptable range. This indicates good insulation performance during normal operation conditions. Next is water contamination. We analyze the insulator and the water combination. Water has a very high dielectric constant, causing the electric field to become more concentrated. This increases the possibility of leakage current and flashover. Therefore, contamination is the most critical operation condition. Okay, next is dust contamination. For dust contamination, the electric field increases only slightly compared to clean condition. The voltage distribution remains relatively stable because dust has a much lower dielectric constant than water. This shows that the proposed design still performs well under dry polluted conditions. Now I will pass the presentation to Imran. Thank you.
Okay, this slide compares the three operating conditions. First is clean conditions provide the best electrical performance. Second, the dust contamination cause moderate changes, while water contamination produce the highest electric field concentration. From the result, we conclude that moisture combined with pollution presents the greatest risk to the insulator. Okay, our design reduced the mean failure mechanism in several ways. The long creepage distance helps prevent surface flashover. Silicon rubber reduce water film formation, and the FRP core provide strong mechanical support. Together, these features improve the overall reliability of the insulator. Although the design performs well, there are several possible improvements. There is high temperature vulcanized silicon rubber can further improve pollution resistance. Second is grading rings may also be added to reduce electric field concentration. And for future studies should include mechanical and thermal analysis using software such as analyse or COMSOL. And for the conclusion is this project successfully designed and evaluated to the 33 kV overhead line insulator for polluted environments. The selected alternating multi-shed design achieved the required creepage distance and demonstrate good electrical performance under clean dust and water contamination conditions. Among all conditions, water contamination produce the highest electrical stress and represent the most critical operating conditions. Overall, the proposed design has strong potential for improving the reliability of overhead transmission system in polluted environment. Thank you for your attention. We are happy to answer any questions.